All right, today we're going to talk about a new specification that's aimed at solving a really common, really frustrating problem in manufacturing. It's called i3X. That's the Industrial Information Interoperability Exchange. And it's all about getting industrial data to speak a common language.
So, let's start with the problem. And it's one I'm sure everyone here knows all too well. In our world, every single custom integration we build isn't just a project cost. It's a new potential point of failure. You know how it is. They're brittle, they're expensive, and honestly, they just get in the way of moving forward. I mean, just picture a typical facility, right? You've got your historian, your MES, SCADA, maybe an MQTT broker, and every single one speaks its own proprietary API. It's a total mess for your applications. Your developers end up hand-coding custom integrations for every single platform. And what happens when you want to switch out a vendor? You guessed it, you're looking at a complete rewrite. Your apps are basically locked in. So how do we get out of this integration nightmare? Well, the answer lies in building a clean, consistent abstraction layer over the top of it all. And that's where i3X comes in. It's a vendor-agnostic REST API specification designed specifically for contextualized manufacturing data. The idea here is actually really simple. Platforms implement the i3X spec, and then your applications can code against that one single unified spec. You just do it once. Now, it's really important to be clear about where i3X fits. It is not here to replace standards like OPCUA or MQTT. Not at all. It's designed to be complementary. Think of i3X as a kind of universal query layer that sits on top of these protocols, giving applications one consistent way to get to the data, no matter where it's coming from. Okay, to really appreciate what i3X does, we need to pop the hood and look at its core concept, which is the data model. This is where the design really starts to shine. The address space is built on a really logical hierarchy. At the very top, you have namespaces. These are just logical containers for scoping your data. Inside a namespace, you define object types. These are basically your schemas, for things like equipment or sensor. And then, of course, you have the objects themselves, the actual instances like Pump 101 or Temp Sensor 3. Now, this is one of the most powerful parts of i3X, and something I think this group in particular will appreciate. Its explicit relationship taxonomy. The spec defines 3 different kinds of relationships. First, you've got organizational relationships, like has-children, for building out your standard plan hierarchies. Second, there are compositional ones, like has-component, which you use when a child object is fundamentally part of the parent. And third, you have non-hierarchical relationships, which let you build out rich graph structures. The key thing here is that the relationships aren't just implied. They are explicit, defined parts of the model that you can actually query. Okay, so that's how the data is structured. Now let's talk about how our applications can actually get that data out. There are really 2 main ways: direct value queries and subscriptions. At the core of all data access in i3X is the BQT triple. That's value, quality, and timestamp. Every single data point comes in this format. And to make life easier and promote interoperability, the quality codes follow the well-established OPCUA conventions, which should be very familiar to all of you. So how do you get these VQTs? Well, for a simple pull, an application can just send a post request to the /object/value endpoint. Easy. But for real-time data, i3X uses subscriptions that push updates using server-sent events. It's a simple, standard way to get a live stream of values. And for those of you dealing with complex, nested objects, there's a handy max depth parameter to control how deep into a compositional hierarchy you want to go. So we've covered the data model and how to access it. Now let's just take a step back and look at the entire API surface at once. As you can see, the whole thing is broken down into 3 logical groups. You've got 6 endpoints for discovery, letting you browse namespaces, types, and objects. Then there are just 2 endpoints for getting values, one for current and one for historical. And finally, 4 endpoints to manage your real-time subscriptions. That's it. It's clean, it's focused, and it's simple by design. And that's really the bottom line. The entire i3X spec is built on just 12 endpoints. It is all JSON, all REST. There's no XML, no custom binary encoding, no complex session management to worry about. It was absolutely designed for simplicity and ease of implementation. So, what's the current status of the project and how can you learn more? Right now, i3X is in a pre-release alpha stage, but the API surface is stable. The spec is maintained by the i3X working group, which is under the CSMII umbrella and includes participants from across the industry.
Companies like Rockwell, Microsoft, and Siemens are all involved.
So if this has sparked your interest and you're curious about the spec itself, the SDKs, or some reference implementations, everything you need to get going is available at i3x.dev. You'll find the full RFC, the Open API spec, all the documentation, and links to get you started. I'd really encourage you to check it out. Thank you.